Welcome to class 10 mathematics. Dear students, today I am going to discuss a new chapter, that is coordinate geometry. Coordinate geometry. You have learnt in your previous class to locate the position of a point on a plane. We require a pair of coordinate axes. Pair of coordinate axes. Those are x-axis and y-axis. Here, this is a origin. X-axis and y-axis will intersect at point, that is nothing but what origin. The coordinates of origin will be 0, 0. Both x and y coordinate will be 0. Along from this 0 to right side, positive x-axis, 0 to left side, negative x-axis, 0 to upside, positive y-axis, 0 to downside, and negative y-axis. This concept already you know. And quadrants, this is a first quadrant, this is a second quadrant, this is a third quadrant, this is fourth quadrant. Location of points on the quadrant already we have learned. In the first quadrant, x-axis will be positive and y-axis also will be positive, both will be positive. In the second quadrant, x-axis will be negative, y-axis will be positive. First, usually we will take x-axis, next y-axis. So in this third quadrant, x-axis is negative and y-axis is also negative. In the fourth quadrant, x-axis is positive, y-axis is negative. So these are the quadrant with the sign. Already we have learned all these. Okay. Now the point is, the distance of a point from the y-axis is called x coordinate. If you have to take any point here, choose like P, this distance will be x coordinate. If the point will be on x-axis, the coordinate of this point will be, suppose you have to consider this distance is x comma y coordinate will be 0. Y coordinate will be 0. If the point lie on y-axis, if you suppose you have to take this is a q, the coordinate of q will be, the distance between this origin to q is y, so x coordinate will be 0 and y coordinate will be 0 comma y. So these are the coordinates. So the distance of a, by using this, see, the distance of a point from y-axis is called x coordinate or abscissa. See, from here origin to P, this is a x coordinate, or we can say this is abscissa. X coordinate or abscissa. Next, the distance of a point from x-axis is called y coordinate or just ordinate. See, from here to Q, this is a y coordinate or ordinate, just simply ordinate. The coordinates of the point on the x-axis are of the form x comma 0. See, any point lie on the x-axis, the coordinate of that point will be x comma 0, and y-axis is of the form, see, y-axis is of the form 0 comma y, because always will represent x coordinate first. By using this, so already we have learned all these in your previous class. This year we are going to learn distance formula, sections formula, and area triangle. What are the applications of those theorems, those formulas? I'll discuss now. Now first formula in this chapter is distance formula. How to find distance between two points by using the distance formula. Now take here, this is a origin, this is x-axis, this is y-axis. Let us consider P and Q are any two points. Join these 2 points. Join these 2 points. Let the coordinates of P be x1 comma y1 and coordinates of Q be x2 comma y2. x2 comma y2. So now you have to find the distance between 2 points. So slowly I will write how to prove this one. So let proof for this is, let P of x1 comma y1 and q of x2 comma y2 are any 2 points, or any 2 points we have to consider, any 2 points. Now draw some, already I have drawn. Draw PR and QS. PR and QS perpendicular to x-axis. See, already done. PR and QS perpendicular to x-axis, and PT is perpendicular to, sorry, PT is parallel to, and PT is parallel to y-axis. See, this PT is parallel to, sorry, x-axis or perpendicular to y-axis. See, this PT is parallel to x-axis. Now OR is equal to, this is a x coordinate, this is p of x comma y, so this distance will be, OR will be x. So OR is equal to x1, because x1 is given, x1 comma y1. OR is equal to x1 and OS is equal to x2. OS, this distance will be x2. This distance will be x2, because the coordinate of q will be x2 comma y2. OS, this is x2. OS is x2. Now RS is equal to, see, RS is equal to PT. RS is equal to PT. RS is equal to PT. These two are opposite sides. RS is equal to PT. That can be written as, how to find RS now? OS minus OR. OS minus OR. OS minus OR gives us RS. RS can be written as, RS is same as PT. That can be found by using OS minus OR, because we know OS and OR. Now we have to substitute, that gives us, that is equal to, OS is x2 minus x1. OS is x2 and OR is x2. So RS gives us x2 minus x1. RS and PT both are same, that gives us x2 minus x1. Now similarly ST is equal to ST. See, ST is equal to y coordinate. This is y1, because ST is same as PR. So y coordinate is y1 here. This is y1. And QS is, see, QS is y2. QS is y2. To find QT, we know these two. QT is equal to, how to find QT? QT is nothing but what? SQ minus ST. We know SQ and ST, that is nothing but what? PR. See, QT is equal to SQ minus ST. See, QT is nothing but what? SQ, O length minus ST gives us QT. That is equal to SQ is nothing but what? Y2 minus ST is same as PR. PR length is Y1. So QT is equal to Y2 minus Y1. Now in triangle PTQ, this is a right angle. Angle T is right angle. So by Pythagoras theorem, PQ square is equal to, PQ square is equal to PT square. See, PT square plus QT square. Now substitute the values. PQ square as it is, PT we know already. PT pt is same as, see, pt value we know, that is x2 minus x1 whole square plus qt is y2 minus y1 whole square. We want pq only. pq is equal to, take square root on both sides, that gives us under square root x2 minus x1 whole square plus y2 minus y1 whole square. This is pq is the distance between two points. So this is the formula, this is the distance formula. So distance between p and q is square root of x2 minus x1 whole square plus y2 minus y1 whole square under square root this one, because pq square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So you can rearrange, you can write this one as x1 minus x2 whole square plus y1 minus y2 whole square, or x2 minus x1 whole square plus y2 minus y1 whole square. Order doesn't matter, x1 and x2, because you will get under square root same value only. So this is the distance between these 2 points. You should remember by using this formula. What are the applications of this formula? We can solve by solving some questions. We can understand what is the distance, what is the application of this formula. Now I will solve exercise 7.1 by using distance formula. First question, find the distance between the following pairs of points. First one is 2, 3 and 4, 1. Solution for this question is coordinate of A. First, this is A, this is B. Coordinate of A, that is equal to x1 is, this is consider x1 y1 x2 y2. This point is A, this point is B. x1 is equal to 2 and y1 is equal to 3. y1 is equal to 3 and coordinate of B is equal to x2. First x2 is 4 and y2 is 1. y2 is 1. By distance formula, distance between 2 points, those are AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This square root should be till end of the. Now substitute the values, that is equal to under square root x2 is 4 minus x1 is 2 whole square plus y2 is 1 minus y1 is 3 whole square. That gives us square root of 4 minus 2 is 2 square plus 1 minus 3 is minus 2 square. That gives us under square root 2 square is 4 plus minus 2 square is minus 2 into minus 2. That also gives us 4. That is equal to root 8. Root 8 is nothing but what? Again it can be written as root of 4 into 2. That gives us square root of 4 is 2 root 2. 2 root 2 units. 2 root 2 units. We don't have any particular. So in generally we have to write 2 root 2 units is the distance between point A and B according to the given points. This is the first one. Now take second one is, second points are minus 5 comma 7 and minus 1 comma 3. Solution, coordinate of A, that is equal to x1 is equal to minus 5 here, y1 is equal to 7. Coordinate of B, that is x2 is equal to minus 1, y2 is equal to plus 3. By distance formula, AB is equal to square root of x2 minus x1 whole square. You can find x2 minus x1 whole square or x1 plus x2 whole square, x1 minus x2 whole square. Both will get same only. x2 minus x1 whole square is plus y2 minus y1 whole square. That is equal to, substitute the values and simplify. x2 is minus 1 minus x1 is minus of minus, that gives us plus 5 whole square, plus y2 is 3 minus y1 is 7, 3 minus 7 whole square, that gives us minus 1 plus 5 is 4 square, plus 3 minus 7 is minus 4 square, that is equal to 4 square is 16 plus minus 4 square is also 16, because minus 4 into minus 4, that gives us 16. Now 16 plus 16 is root 32. Root 32 can be written as root 16 into 2, that gives us root 16 is 4 root 2, 4 root 2 units. Therefore, the distance between 2 points is 4 root 2 units.